So this is number 18 from the homework for 9.4, Law of Cosines. And a student in my first period class asked me to talk about this right at the end of class. And we answered the first question, part A, which is all geometry actually. And we never got to the cool pre-calculus using law of cosines for part B. So I decided I would put this together, animate it, and then put a little video up for you guys in Google Classroom. So I hope you enjoy it. This is my diagram right here of the diagram that's in your textbook. It's not as good as the textbook diagram, but it has everything we need. And here's the problem right here. An oil well at A, so you have an oil well right here on top of this hill, drilled 3,400 feet before it hit a shale ledge. So you see that this is my shale ledge right here, and this is all dirt right here within this triangle. So that implies that this distance right here is 3,400 feet. The same ledge was only 1,950 feet deep from when drilled from B. So we have another oil well over here, and this is 1,950 feet right there. And then they say the hill and this is oil well B is 8,000 feet downhill from oil well A. So that's 8,000 feet right there. Okay, pretty cool. And I don't remember how much of that was actually in the given diagram, but I went from scratch and kind of went as if we didn't have a diagram at all. Anyway, the hill is inclined at 15 degrees to the horizontal. So that means at this point B right here, I could put a horizontal. And if the hill is inclined at 15 degrees, that means this acute angle right here is 15 degrees. Okay, so what does that tell us about some of the angles in the triangle? Well, do you agree that the horizontal and the vertical well, that's a 90-degree angle? So if this acute angle is 15 degrees, then this angle right here would have to be 75 degrees. And then implies we could have done the same thing right up here at A, but this would also have to be 75 degrees up top right there. Okay, so that's all of the given information in the problem into the diagram. And again, I'm trying to model diagramming and just reading the problem and putting given information right into the problem using a lot of geometry and such. And then part A, how far down from B would you expect the shale ledge to emerge? So see that point right there? That's where the dirt from the hill, and if you kept going, this is shale now right here, because this is all a big old shale ledge. So they want to know the distance from B to that point right there. So let's throw a variable in there. How about we call that an x? Okay, now at first I'm looking at this thinking, okay, well, we're doing law of cosines and we've done law of sines, so can I use law of cosines directly to find this x right now? Now what I do have is this 75-degree angle, and I do have this side of 1950, but I don't have the opposite of the 75-degree angle, and I don't have the opposite of side x. I don't have that angle right there. So I thought, okay, what are we going to do? And then if you look closely at this diagram, what I see are two similar triangles. All right, I see this triangle right here, and then I see the whole triangle. And those two triangles are the same shape, but not the same size. So those are similar triangles. And go back to geometry, and your geometric proofs aren't corresponding parts of similar triangles proportional. So we can solve this x using geometry in a simple proportion. So I'm going to set up similar triangles, this proportion right here where I'm solving for x. So I'm going to go x over this leg of the smaller triangle, 1,950, would have to equal, now take that same dimension of the larger triangle that's similar to the smaller triangle. So this total distance from this point to well A would be x plus 8,000 over, and then this leg of the larger triangle, 3,400. Now, we just solved this proportion for x. So let's cross multiply. So I see 3,400 times x would have to equal the 1,950 times x plus 1,950 times 8,000, and I punched that out, and I got, and I didn't put any commas in here, but that's 15,600,000. Now you just solve for x. And you guys, I'm sorry, but for this, I skipped a lot of steps, but I subtracted 1,950x from both sides, and then I divided this number by the coefficient I'd get on the left when I combine the terms. So I did that all on my calculator. In fact, I'll do that with you right now. Let's try to do that on our calculator. So let me see, what's 3,400 minus 1950? 3,400 minus 1950, all right, and that number is 1,450, and so I have on the left, I have 1,450x equals 15,600,000. So to solve for x, I'm going to take that 15,600,000, and I'm going to divide by 1,450. And I hope I put that into my calculator correctly. All right, 15,600, yeah, 15,600,000 divided by 1450. And remember now, I'm getting this ugly decimal of 10,758.62069. But in this chapter, we're rounding all distances to 3 sig digs. So that would be 10,800 feet, approximately. I should have an approximately right there, okay? But that's all right. 10,800 feet. Okay, so now I have this x right here, all right? And that's the answer to A right there. Please make that an approximately, though. And then B, what is the angle between the ledge and the hill? So they're talking about this angle right there, okay? And let's see, can we use the law of cosines to find that angle? Well, let's see, there it is right there in law of cosines. Now, at first, I'm thinking, okay, I have side angle side right here, so I should be able to use law of cosines to solve this problem and find that. But what I don't have is the opposite of the 75-degree angle, nor do I have this angle, which is the opposite of this x right there. So it would take a lot of work to get there that way. So I thought, well, how about if I use the big triangle right here and find this side right there, which I'm going to call y. And by doing this, I'm going to be able to use both forms of my law of cosines. So I'm thinking, if I'm going to find this y right here, what do I have right here? Well, I have side, all right? I have this angle, all right? Well, I'm finding that angle, and I have this side. And over here, I have this angle and this side. So I have a whole bunch of side angle side going on right there. So let's put this together. Now I'm going my general formula right here, law of cosines, all right? So this c in the c squared is actually that y right there. And in general, doesn't c squared always equal a squared plus b squared? Do you see your Pythagorean theorem right there? But then this is not a right triangle, so we need the minus 2ab cosine of the included angle c. All right, now that's my general law of cosines right there. But let's put it in terms of the stuff we have in our diagram. So that y squared would equal, okay, and now you think about this, you've got all these adjacent sides to this 75-degree angle right there. So what was that x again? That was approximately 10,800 plus 8,000. So this whole side right here is approximately 18,800. And I'm going to have to square that. And then the other leg with this included angle of 75 degrees, that would be this 3,400. Let's square that. There's my a squared plus b squared minus 2 times the a, 18,800, times the B, 3,400, and then cosine of our included angle, which is that 75 degrees. All right, now for y, we're just going to take the square root of all of this, okay? And let's all punch this out right now, even though I'm not showing it on the PowerPoint. Practice your calculators. Let's go second square root of 18,800 squared plus 3,400 squared minus 2 times 18,800 times 3,400 times cosine of 75 degrees. Cosine of 75 degrees. Now I get really frustrated when my calculator, I put an expression that is so long that I can't see everything. So I can't double check it, but I'm gonna count on I put that in correctly. And I am getting right here 17, remember 3 sig digs, so that would be 17,900. And here I've got 18,200, so let me double check everything again. 18,800 squared. Oh, I missed a 0 on my 3,400, and I couldn't check that before. So I'm just going to go second entry, and I'm going to arrow back to that where the 3,400 should have been, and I've got to insert one more 0 there. Second insert, another 0 right there. Okay, now it should be in correctly. And now the 3 sig digs, I'm getting the 18,200, and that would be in feet that I was expecting to get. Okay, so that's it. Now look at what I have, okay? I actually have side, 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 and I can use that to find this angle theta. Okay, so that means we're going to use our other form because we're looking for an angle. So instead of going c squared equals a squared plus b squared minus 2ab cosine of c, can I go cosine of my included angle c equals, and then I've got my legs a squared plus the b squared minus the opposite squared minus c squared over 2 times a times b. All right, so let's put that in the language of this triangle right here. We're not looking for angle C, we're looking for angle theta. So I'm going to go cosine of theta is, and what's adjacent to theta? Well, there's 2 adjacents. One of them would be this x, which was approximately 10,800 plus 8,000 more, so that's an 18,800 that I'm going to have to square. All right, plus the other adjacent is this y that I just found, which is approximately 18,200 feet, so let's square that. 18,200 squared minus this opposite of my angle theta, which is 3,400, and square that. 3,400 squared over 2 times the a, which was 18,800, times the b, which was 18,200. All right, wonderful. Now, again, we've got to be careful here, but let's go inverse cosine of that entire right-hand side of that equation to solve for the theta. And I probably won't be able to see it all, so I'm going to be extra careful this time. So, second cosine for inverse cosine of, and then I better put my numerator in parentheses, so an extra parenthesis there, 18,800 squared plus 18,200 squared minus 3,400 squared, and then close my numerator with a parenthesis, divided by, now you got to think like a calculator here too, okay? And you're going to go, if I go 2 times 18,800 times 18,200, my calculator's not going to understand, so I'm going to put this divisor in parentheses too. Parenthesis, after my division symbol, 2 times 18,800 times 18,200, and close the divisor and close my inverse sine. All right, and man, I wish I could double check, but I can't. I could arrow back, I suppose. I'm going to do that because I don't want to have to redo this one. So I see inverse cosine, and let me read this to you exactly the way I have it in my calculator. Inverse cosine of open parenthesis and then another open parenthesis of 18,800 squared plus 18,200 squared minus 3,400 squared, and then I close that parenthesis, and then I'm going to divide, and I'm dividing by parenthesis 2 times 18,800 times 18,200, and I close my divisor, and I close my inverse cosine, and everything's in perfect. Look, I checked that one, and it's got to be perfect. And so I am getting 10 point, and we have to round our angles to the nearest tenth of a degree. So that theta is approximately 10.4 degrees. And we have answered that question. That is a really, really cool problem. All right, so if you have any questions, give me an email, and I'd love to talk to you about this problem more. Thank you, and you guys have a great day. And good luck on the rest of your homework.